Welcome to Epione Biotech. My name is Ruben, and today I'll be walking you guys through the lateral connector piece for our handheld suturing device. This is the piece that connects the end attachment to the overall handle and the handle hinge itself. And today I'll be walking you guys step by step through the history tree and allowing you guys to be able to recreate this step by step. So if we go ahead and look at our first sketch, we can see that we have a little rounded off edge piece right here. This is the part that connects to the hinge and is able to rotate this side to side. Now what we start off with a 0.75 line right at the bottom here at the origin. This part right here was actually then on the front plane. I then put a center line at the midpoint straight up, so then I could go ahead and mirror this line across this center plane and get all the constraints in there. I then made a 3-point arc using the center right here, and I went ahead and this was the same radius or diameter as the 0.75 sketch down here. And so I added in all of the relationships, made all the lines coincident, and these two lines parallel, and thus this little sketch right here was formed. Now this piece right here needed to be extruded, so what we did a boss extrusion that was 0.5 from the midplane, and you can see here that the extrusion was a midplane extrusion right here, and we went ahead and knocked that in. So the next part after that was we went ahead and we made a sketch over here to create the hole. Now this sketch was actually a little bit too small, as you'll see in the later part of the demo design, but what we did was we were able to go ahead and make this cut right here for 0.2, and we then mirrored it across the front plane so that it went all the way through. So if you can see, if you exit the sketch, if we go ahead and look at the cut, was a blind cut that was mirrored all the way through, therefore the entire cut goes through as seen here. Now as we move on to the next part of the piece, we'll look at the next sketch, and this next sketch was the piece that allowed us to create, if we exit this real quickly here, this little indentation right here. So what we did was we took and sketched on the front plane again, and what we did was we went ahead and sketched on the front plane. We sketched the circle from we used the midpoint right here. We sketched a circle with diameter 1 inch, and then created a smaller one with the diameter of 0.75 inches inside of that. And so what that did was we were able to then take this and cut this through. So if we look at this cut extrusion right here, exit the sketch, we were able to cut through around, let me see right here, if we look at that, we were able to cut through 0.32 inches deep going into the device. This allowed us to just cut this outside circular part right here to have this lip inside, and thus be able to wrap our band around that. And then we moving on, to the extrusion part down below, is what we did after that was after this part was done, we went ahead and sketched some more lines. So I'll go ahead and show this. So what I did was I took this bottom piece right here, this bottom face, and went ahead and took out 0.65 and I mirrored it across this line right here, so that it would be both the same measurements and also constraints. And it was just basically this little edge piece right here that would be able to hold and house and support that end attachment piece. So this was 0.65 inches long, and it was mirrored across this center line right there, or guide line right there. And once that was in place, we could go ahead, and then I knew I wanted to have a little lip so that it could hold the attachment piece. And so this lip right here is, if we go ahead and we go back to that sketch right there, that lip is actually a cut extrusion down. So what we did was I went ahead and we boss extruded this entire thing out. And this boss extrusion was around 1.60 inches, enough to hold the entire end attachment piece. And so that was extruded out, and then what we did was we went ahead and if we took a look at this measurement right here, we went ahead and we cut 0.18 inches off of that. So we went ahead and sketched on the plane again. I sketched 0.57 inches. This is just to give it so it was a secure fit. And we then cut this extrusion off right here. So if we look at the cut extrude, this was the cut right there. So that was 0.18 inches, and it went not all the way deep, it only went 1.5, so there's a little bit of support right here as well left over. And we then went on to the next cut extrusion, which was getting the guide rail in for the attachment piece. Now this was these measurements right here. This fit the end attachment piece perfectly, and it was 0.5 across here, 0.20 up, and then if we take these measurements and subtract it, we have 0.25, so these are around 0.125 inches on each side. And this fitted perfectly so that the end attachment piece could slide right in and just be held in place there. So that was added by sketching on this plane right here and then going ahead and cutting it through 1.5 inches as well. So there we have the cut extrusion, so for the attachment piece to go ahead and slide on through. We then go ahead and I went ahead and I shelled the entire device. How I did that was I went ahead and I just selected each area and pressed shell. And I did a 0.1 shell so that I could go ahead and have, for when we went ahead and 3D printed, there wasn't as much material needed, therefore reducing our costs. That's a completely optional step. You could go ahead and have this fully filled in, but that would just mean that you're printing more. And the structure overall when we printed it was very sound. Finally, we went ahead and we extruded out 2 holes for pins to slide through so that the attachment piece could go ahead and attach down to this bottom piece more securely. What I did was I went ahead and sketched on this front plane right here, or this top plane right here. And what we did was for taking 0.63 up, this is in conjunction with the attachment piece as well. We made a circle 0.25 in diameter and about 0.36 in from the edge of the piece right here. And so once we did that, we went ahead and we just cut it through all so that it would go through the entire piece. So you can see there that the holes are through all. And then finally, getting towards the end here, we went ahead and made this little guide piece right here. This is probably the most interesting part of the device. So what we did here, if we look at this sketch itself, this was not it, sorry. If we look here at this boss extrusion, it was basically taking this circle here from the previous sketch 12 right here, taking that circle and using the plane, we went ahead and sketched down 0.25 inches and then used another arc stemming from the midpoint right here, that is a common center point, 0.45 radius, and we went ahead and just trimmed the rest of it off. So taking that, we went ahead and extruded it. This small extrusion right here, that was around 0.075 inches, this is a very small extrusion. This created the lip for our entire hinge part. So this allowed the band to wrap around without sliding out, still fit in through this little gap right here. And that allowed us to securely move this lateral connector piece side to side without having the fear of the band slide off of it. And going back, there's only one thing I missed, and this was the extension of the hole. So when we printed it out the first time, we realized that 0.2 wasn't enough, so we went ahead and made another extrusion. So right here, we have a 0.25 hole, and this you can see is just cut through the entire thing. It's cut through all so that we can have a slightly larger hole so that can fit a larger axle. This allowed us to move the lateral hinge piece a lot easier than before. But other than that, that is the lateral connector piece. It is pretty. I would say it's fairly okay to follow along and recreate this piece. The trickiest part is probably creating that lip right there. But for now, that's it. Thank you for watching, and this is Epione Biotech.